Ever wondered why, despite the billions of stars and planets in our universe, we've yet to encounter any signs of extraterrestrial life? It's a question that has puzzled scientists, philosophers, and space enthusiasts alike for decades. Our universe is unimaginably vast, with an estimated 2 trillion galaxies, each filled with billions of stars. Around these stars, there are planets, many of which could potentially harbor life. And yet, despite the astronomical odds, we haven't detected so much as a blip on our radars. Not a single message, not a single spacecraft. Nothing to suggest that we are not alone in this grand cosmos. The statistics seem to suggest that we should have already stumbled upon some evidence of alien civilizations, and yet the silence from the universe is deafening. This perplexing silence, this apparent contradiction between the high probability of extraterrestrial life and the lack of contact or evidence, poses what we call the Great Question. This conundrum is what's known as the Fermi paradox. The Fermi paradox isn't actually a paradox. It's a question, a mystery wrapped in the fabric of our universe. Now let's break it down. Named after the physicist Enrico Fermi, the Fermi paradox is the apparent contradiction that comes to light when we consider two facts. First, the sheer scale of the universe suggests there's a high probability of extraterrestrial life. We're talking about approximately 2 trillion galaxies, each with millions, if not billions, of stars. Around these stars, it's likely that there are countless planets, many of which may be similar to Earth. The second fact is where the paradox comes in. Despite this high probability of alien life, we've yet to make contact with any extraterrestrial civilizations. We've sent out radio signals, probes, and even a golden record aboard the Voyager spacecraft, all in the hope of making contact. Yet, the universe has remained eerily silent. This leads us to Fermi's famous question, posed during a casual lunch chat back in the 1950s. Where is everybody? This simple question holds profound implications. It questions our understanding of the universe, our place in it, and the future of our species. Are we alone in the universe? If not, then where are all the other civilizations? Are they too far away, or perhaps they're avoiding us? Or could it be that they've come and gone, leaving us behind? The Fermi paradox doesn't provide answers, but it does spark curiosity and invites us to question, to explore, and to dream. It's a cosmic riddle that challenges us to look beyond our own world, to consider the possibilities that lie within those twinkling stars and distant galaxies. So why haven't we found them, or why haven't they found us? Let's delve into some theories. One possible answer to the Fermi paradox is the concept of the Great Filter. The Great Filter hypothesis is a potential explanation for the deafening silence we experience in the cosmos. It's an idea that suggests somewhere along the journey from the simplest form of life to a civilization capable of harnessing the energy of an entire galaxy, a so-called Type 3 civilization, there exists a formidable barrier or filter. This filter is so challenging to overcome that it prevents or severely limits the progression of life. So what could this filter be? Well, it could take many forms. It might be a physical event, such as a global catastrophe. Imagine a meteor of colossal size hurtling through space and colliding with a planet, causing untold devastation and possibly leading to the extinction of life as we know it. Or it could be a gamma-ray burst, a sudden intense explosion of energy that could strip a planet of its atmosphere in an instant. The Great Filter could also be a biological hurdle. Perhaps the leap from non-living matter to the first living cell is an incredibly rare event that few, if any, manage to achieve. Or maybe the evolution of complex multicellular organisms is a hurdle too high for most life forms to jump. But perhaps most chillingly of all, the filter could be self-inflicted. It's conceivable that any civilization advanced enough to communicate with us may also be advanced enough to destroy itself. Whether it's through nuclear warfare, a biological disaster, or some other form of self-destruction, it's plausible that civilizations tend to wipe themselves out before they can make contact with others. The Great Filter hypothesis is both fascinating and terrifying. It offers a potential answer to why we've yet to detect signs of extraterrestrial life, but it also raises an unsettling question. Where is this filter located in the grand timeline of life's progression? If the Great Filter is ahead of us, it means we have yet to face a major obstacle that could potentially wipe us out. Another possible solution to the Fermi paradox lies in the limitations of interstellar travel. Even with our current understanding of the cosmos, the sheer vastness of space presents a formidable obstacle. To put it into perspective, let's consider our closest stellar neighbor, Proxima Centauri. It's roughly 4.2 light-years away. This means that light, the fastest thing in the universe, traveling at the mind-boggling speed of 186,000 miles per second, takes over 4 years to reach us from there. Now, imagine attempting to traverse this distance with our current technology. Our fastest spacecraft to date, the Parker Solar Probe, moves at an impressive speed of about 433,000 miles per hour. However, even at this breakneck speed, it would take us approximately 6,800 years to reach Proxima Centauri. That's longer than all recorded human history. And remember, this is just our nearest star. The Milky Way, our home galaxy, spans a whopping 100,000 light-years. These vast distances are one side of the coin. The other side is the technological challenges of interstellar travel. We're talking about the need for massive amounts of energy, the ability to sustain life for incredibly long periods, and the risk of collisions with space debris at high speeds, just to name a few. And even if we could overcome these challenges, there's still the question of whether it would be worth it. After all, just because a planet is in the habitable zone does not guarantee it hosts life, let alone intelligent life. To sum it up, the constraints of interstellar travel could be a significant factor in explaining the Fermi paradox. We might not be alone in the universe, but the hurdles of space travel are monumental. So the universe might be teeming with life, but the vast distances and technological barriers mean we might never meet them.